Hi, AP Calc. We're talking about week 13, problem number 25. If you take a look, we're looking at the first derivative. So looking at that first derivative to find points of inflection, we have to look at the second derivative, which is the slope of f prime of x. So I have points of inflection at 1 and 3 because I have that change in slope. Okay, at x equals 1, I go from a positive slope to a negative slope, and here at 3, I go from a negative slope to a positive slope. Okay, we cannot be using the fact that there are max mins on f prime to justify our points of inflection. Many of you went through the step process that we had explained about going through, and that was perfect as well. Okay, the harder one is part B and figuring out the absolute maximum and minimum values. Okay, and you need a table and you need to compare some things. So in other words, when you're going through this, yes, I know that most of you knew that the minimum was at 4, okay, but what I wanted you to see is that you have to somehow compare. So you have to talk about the fact that -1, that you know that the integral, the integral from -1 to 1, okay, of f prime of x, so that area under the curve, okay, is going to be greater than the area from -1 to 4. So in other words, I have from -1 to 1, okay, that's one negative value. We know that that's going to be less than 0. We know that this guy's less than 0. However, we also know that this is going to be even more negative since I am going in, or I'm decreasing. So we know that this is going to be that absolute minimum. So we had to compare these, okay, to eliminate -1 from being an actual -1. That integral is going to be 0, but we had to eliminate 1 from being a possible absolute minimum, okay? So we know that at x equals 4, we have an absolute minimum by that comparison of areas under the curve. The next thing we need to compare is we need to compare which one here at 5 or at -1 is going to be the absolute max. Okay, so we're not sure about that. But what we do know is that the integral from -1 to 5 of f prime of x, okay, we know that that is going to be f of 5, right, minus f of 1. But what we also know is that this whole quantity, or I should say this whole quantity, the integral, that area under the curve, is going to be less than 0. So I know that f of 5 is going to, minus f of 1 is going to be less than 0. So I know that f of 5 is less than f of 1, -1, sorry, -1. Okay, f of -1, which tells me that this isn't my absolute max. My absolute max is here at 1 since it's bigger than f of 5. Okay, so eliminating 5 as your possible maximums was worth a point. Okay, this guy, g prime of x, I'm hoping you use product rules, so f of x plus x times f prime of x, right? You got that, and if you do g prime of 2, you're going to get f of 2 or plus 2 times f prime of 2. And if you do that, I believe you get a value of 12. So, you get a value of 4. And you know that g of 2 is literally 2 times f of 2. So you're going to end up with 12, I believe. So y minus 12 is equal to 4 times x minus 2. Okay, so if you're struggling on this tangent line, I'm a little stressed for you. Okay, so I'm going to go to problem 26 now. 26 asks, use the data to approximate w prime of 12. There's a couple of different ways we can do that. Okay, they want you to get the change. So we can either sandwich that guy in the middle right there, or we can compare these two, or we can use these two. Okay, I tend to sandwich mine in the middle. So if I do that, then I'm going to have the slope is going to be w of 15 minus w of 9 all over 15 minus 9. And I'm going to get negative 1/2 degrees Celsius per day. Okay, as long as you had units, you were fine, and you should probably show this. If they want to know w prime of 12 is approximately negative 1/2 degrees Celsius per day. Okay, for the second one, it's doing a trapezoidal method, so I'm just going to do average temperature. So they're telling me approximate the average temperature using trapezoidal. Okay, that's going through my graph every 3. So 3, 6, 9, 12, 15. Right? And doing my trapezoids, whatever those may be, blah, 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 blah. Okay. All right. But what you needed was your height was always 3, right? So you needed to make sure that you go through, and if you're going to find the average, you need 1/15 times that area, because we're going to divide by 15. Okay, to all those areas. Now, you need to add up those trapezoids. They want to see trapezoidal method. I'm not writing it out. You write out all the trapezoids that you found the area of and total them up. Okay, it should be 1/15 times, I think the total was 376.5. So it was that average is approximately 25.1 degrees Celsius. Now, if you got something crazy, can you please go check your average? I had 2 people get like that the average was like 75 or 95. Friends, look at these numbers and make sure that your average is somewhere in that neighborhood. If you're getting 74 as the average, you need to rethink about how you're calculating average. It's just one way to find your errors. Okay? For part C, they're asking you to find the rate of change, actual P prime of 12, but then it says using appropriate units, explain the meaning of your answer in terms of the water temperature. Okay, P prime of T, or actually, you know what? No, I'm not even going to do that. We're not going to get P prime of T. This is a calculator question. So I want P prime of 12 is equal to blank. Okay, you are allowed to use your calculator. Go do n derive, okay, at 12 and get that answer, which ends up being, I believe, negative 0.59, 549 degrees Celsius per day. But then when it says using appropriate units, explain the meaning of your answer, this is where they just won't take this degrees Celsius per day. They want at T equals 12, the temperature is decreasing. They want you to tell them a story. What's happening? Decreasing at a rate of 0.549 degrees Celsius per day. They want, this is the story they want, and they want it at that time T equals 12. So make sure that you pinpoint when exactly that's happening. Okay, same thing here, average value. Okay, all they want, average value, 1/15 time from 0 to 15 of P of T dt. Lord have mercy on your soul if you're going to try and integrate that by hand. Don't do it. Go to your calculator and calculate that N int or Fn int, okay? And you end up with 25.757 degrees Celsius, okay? Let me know if you have any other questions.